sustained, way over
Yeah,
1 mile an hour winds. Yeah.
yeah. And 3 feet of water.
And
So
3 feet of water. Exactly. Yeah. Okay. Well, big thanks to NASA for this really cool visualization of Earth with all the orbiting satellites and stuff. It is amazing how studied the Earth is today, you know. I think it's the cause sometimes for instant alarm when we see something change, uh, but it is really amazing what we've learned about weather and ocean temperatures and currents and uh, surface temperatures, pollution, dust. For a long time, I think humans were blissfully unaware of things.
the all important dust, the
Yes.
bane of astronomers' existence.
Yeah, that's right. Okay. It's time to get started, folks. Here we go.
A balloon mission from NASA observed rare electric blue clouds. These are polar mesospheric clouds, or PMCs. They are only visible during twilight and form above Earth's polar regions at the upper reaches of the atmosphere. As Earth's uppermost clouds at around 50 miles high, PMCs are composed of ice crystals that glow a bright blue or white when reflecting sunlight. They are extremely sensitive to environmental factors like water vapor and temperature. Atmospheric motions like airflow over mountains or thunderstorms can disturb the atmosphere and cause waves that can propagate to very high altitudes. These waves are known as gravity waves, and although they are invisible, they can be seen as they move through PMCs. Gravity waves lead to turbulence, chaotic movement in the atmosphere that can influence weather and climate and their predictions. But the exact causes and effects of turbulence are not well understood. To better understand this complex process, scientists sent a giant balloon to observe gravity waves in PMCs.
1,200 feet per minute. See you in Canada.
The crewless balloon traveled to 50 miles high and floated from Sweden to Canada over 5 days in July 2018. A laser radar on the balloon measured the PMC altitudes and the atmospheric temperature that affects their formation and brightness. And from 6 million camera images captured from the balloon, scientists could see both large and small ripples caused by gravity waves. A better understanding of turbulence can help improve weather forecast models and our understanding of processes around Earth, which affect our satellites and assets in space.
Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and you are watching the 157th Global Star Party with the theme of cloudy nights. This theme was promoted by David Levy, and I think it's a great one. We were lucky enough to get Mike Beeler, who heads up the Cloudy Nights community, and he'll be on a little bit later. But David, thank you for suggesting this. And, actually the next themed Global Star Party as well. I hope that we're hoping to actually also have kind of an in-between Global Star Party where we are focused on Comet A3. And, if it's as amazing as what everybody predicts, maybe we'll get some live views from around the world. But I'll turn it over to you, David. Thank you.
Well, thank you. We're all excited about Comet Sushin Atlas coming around. And somebody said it's going to be -7. You didn't hear that from me. It'll be what it is. That's the one thing I've learned from a lifetime of observing comets, is that comets are like cats. They both have tails and they both do precisely what they want. And I want to tell you the story. It does relate in a way to the Cloudy Nights theme, although after that story, there's something that directly relates to the Cloudy Nights theme. But Wendy and I were in London, England, and we were just walking by the shops in downtown London, and I chanced upon a telescope store there. And of course, it's kind of like I'm gravitationally attracted to it. And I started looking in the windows, and there was a Questar in the window. And Wendy came, and she was with me, and she said, "David, I need for you to be very honest with me right now," because she looked at the price of the Questar, and she said, "Can you tell me honestly that this telescope, Questar, is 10 times better than the Meade ETX that we have?" And that's costs about $700. And I looked at her and I said, "Sweetheart, the Questar is better, but there ain't no way it's 10 times better. Not a chance." And she said, "Thank you for your honesty." And about 6 months later, she announced that we were going to have dinner with our friends from Arizona, Dean and Donna Koenig. And when we got to the table, there was this telescope sitting in a box with a lovely bow on top of it. And she said, "This is your telescope, and you promised to call it Cupid in honor of our love for each other." And I was just overwhelmed. And that was around 2000 and so. And so I've had it all these years. I still use it. It's a lovely, lovely telescope. And now for our theme of Cloudy Nights. Being born in Montreal and raised there, I'm very familiar with cloudy nights. And even here in southern Arizona, we get cloudy nights. But the most famous cloudy night that I remember was on March the 23rd of 1993, when the sky began cloudy, but then it started to clear after dusk. And we took a couple of images that turned out, that turned out interesting. In fact, the first of the images that I took on this night that had partial clouds, Jupiter was very close to the guide star. And I said, "I don't know how you even got on this, because the reflection from Jupiter is swamping everything in the eyepiece." But I managed to catch the star, and they did a good guide on it. And 2 days later, these clouds had thickened to the point that there was no snow up at Palomar. And I was reading email. Jean Shoemaker was reading Time magazine, which she really enjoyed, and Carolyn was scanning. And suddenly she said, "I don't know what I've got, but it looks like a squashed comet." And Jean, of course, wanted to look at this thing, and Carolyn got up and walked towards me. And I looked at her, and Carolyn and I love to tease each other. But I looked at her and I said, "You are joking, aren't you?" She looked back at me very seriously and she said, "Not this time." And that was the opening of the discovery of comet Shoemaker-Levy 9, taken on a mostly cloudy night. And now comes the quotation for this cloudy night, because even up in northern Arizona, where Clyde Tombaugh was searching for Percival Lowell's Planet X, his search was interrupted time and again by cloudy weather. But he finally discovered it on the 18th of February 1930 on images he had taken on the 23rd and the 30th of January of 1930. And immediately after he found the images, he knew he had it. And he walked across the hall to his colleague Lampland, and he told him that he had found the Planet X. And as Lampland was looking, Clyde decided that he better tell the director. And V.M. Slifer, Vesto Slifer, was sitting in his office. And so Clyde sort of went to a mirror and did his tie up a little bit. And tried to look a little more human. And he sort of walked with a bit of a strut to the director's office. And he walked in and he said, "Dr. Slifer, I have found your Planet X." And Slifer actually got out of his chair as if he had been sitting on a spring. And he ran to the stereo comparator, and Clyde following him. And Lampland said, "This looks pretty damn good." Anyway, Clyde stayed at Lowell until the 1940s, when on one very sad day, Slifer fired him. He said that, the reason is that we've just ran out of funds, but there was a lot of funds to hire other people. They just wanted to get rid of Clyde, and he never got over it. And we talked and talked and talked so long about that and the feelings that he had at Lowell, both good and bad. But that leads me to the quote, which comes from my biography of Clyde Tombaugh, as we read how Clyde left the observatory. He moved first to Albuquerque and then to Las Cruces. But the final paragraph of that chapter is about the telescope and the feelings of the telescope, which I quote to you now. The telescope Clyde Tombaugh was finally about to leave stayed at Lowell. Its long career not nearly over. Years later, director Arthur Hoag claimed that with its many projects, the 13-inch had become one of the world's most productive telescopes. If it had consciousness, it might have wondered about what would happen without the man it had shared a life with. A man who had never quite given up searching one more pair of plates for hidden treasure. A man who called himself a traveler, going over the next hill with an eternal hope. Thank you very much. And back to you, Scott Roberts.
Well, thank you very much, David. I can't imagine doing one of these global star parties without you. You really set the entire pace and tone for these events. And we've done almost 160 of these, okay? And that each one is, a few hours long. So we've got tons of presentations, everything from citizen science to people experiencing astronomy for the first time, art, poetry, everything in between. And so it's always an honor to do it with you, David. Thank you, man. Thank you.
Well, thank you. Thank you so much, Scott. One of the things that I remember when I wrote that paragraph, I brought it to Clyde and Patsy's house and showed it to them. And so help me if Clyde didn't have a tear in his eye as he's reading that. Because like me, he believed the telescopes did have consciousness. And they talked to him, they showed him things. And especially in these disappointing years after the loss of my wife, Wendy, to go out into the observatory And to be with those telescopes is almost like being with people again.
Yeah.
And I just wanted to share that.
Yeah. Well, anyone that knows telescopes as well as you do, David, I mean, they're just a natural extension of you. So that's very cool. That's very cool. As they become for many of us that love our telescopes and use them regularly. So whatever telescope you have, whether it's a small toy telescope or if you got a nice large instrument, with all kinds of computer capability, get out and use it and try to squeeze every last drop out of it. You'll be amazed what you can get. So, yeah. Okay. Well, thank you, David. Thank you. Our next speaker will be from the Astronomical League, and it'll be Mr. John Goss. And his talk is about the loneliest planet. And so here we go.
Yes, sir.
John, the loneliest.
The loneliest planet. Thank you.
Oh,
Thank you, Scott.
no.
No, it's not a sad story.
Okay, well, that's good.
No, it's a good story. It's one of those things in which I think about a few weeks ago, I think we had Scott Harrington on AL Live.
That's right.
Or
Yeah.
similar to this. And one of the things he likes to say is that you do observing as much with your mind as you do with your eyes.
Oh, of course.
You
Yes.
know, and I think what I have to talk a little bit is concerns some of that. So I'd like to jump right in
Okay.
and see what I can do here. Great. Before I do, let's talk about this year's upcoming AstroCon, which is an Alcon in July. Oh, excuse me. I'll jump ahead with that. Our next AL Live guest speaker will be Barbara Harris, and we hear so much about these automated telescopes, electronic telescopes, and so on. And she's going to talk about C-STAR. It's on a lot of amateurs' minds these days. There's a lot of talk about this, but she's going to talk about, as you can see, with the title "Doing Science with C-STAR." So that'll be on October 25th, which is a Friday night.
Excellent.
But also want to give a brief plug for AstroCon 2025 in Bryce Canyon on June 25th to the 28th. And I'll zoom in to tell you some good things about this. A lot of workshops are going to be featured, including about imaging, which you could imagine, but also about sketching, about how to describe what you see, taking journals, a little bit about eyepieces and filters and books and so on. So this is something that we have provided in the daytime as well as at night. Because at nighttime, this is another thing I was kind of jotting down some notes on why you would want to go to AstroCon, or really to any dark sky area. I have a dozen or so reasons why you want to go out at night this place. But I put some reasons for Bryce Canyon on why you'd want to go in the daytime as well. There are some pretty incredible sites and geography and hikes and wildlife and all that at Bryce Canyon. So you can do all that in the daytime as well as visit astronomy vendors. Little plug for AstroCon. So let's just jump right in. The loneliest planet. Well, I'll just tell you the loneliest planet is Neptune, which we're going to go to next. The Astronomical League has at least 2 observing clubs which feature Neptune. One's the Galileo Club. Galileo observed Neptune in December 1612. But what we would like you to do is just to jot it down, to say you observed it, make sure you can identify it. With binoculars, you won't be able to see much. With a small telescope, you won't be able to see much either, but we'll get into that right now. I think a lot of us realized that when we were growing up and learning about the solar system, the order of the planets, this is what we saw. You know, the sun, you got Mercury, Venus, Earth, Mars, and so on. And that's sort of a beginning, but as we got a little older, we realized, no, there's a big spacing to these things. Earth and Mars are pretty close to the sun. I didn't even represent Mercury and Venus, of course. But you can see as you go further out, spacing gets greater and greater and greater, which sort of leads into why I'm calling Neptune the loneliest planet, because it's roughly 30 times the distance from the sun that our own planet is. What's going on here? Here we go.
There you go.
Now a little bit better representation. This is more of a perspective on how things are situated right now. The planet sizes are, of course, grossly enlarged here, but the distances are pretty much proportional. That's surprisingly, right now, Saturn is closer to Neptune than Uranus. You know, in our first depiction of these things, you think that, okay, you got Uranus and then you got Neptune. Well, not now. You got Saturn is closer to Neptune than Uranus. And it's going to remain that way for quite some time. And I think 2032, Jupiter becomes the closest planet to Neptune. Kind of weird, kind of weird. But I'd like to start out really about discussing a little bit about Neptune and how it was discovered. I mentioned a minute ago or so that Neptune was really first seen by Galileo. He didn't realize it. This is a sketch that I drew from what he saw on January 27th, 1613. He saw it a number of times. By some really strange coincidence, Jupiter happened to be in conjunction with Neptune right when Galileo was looking. In fact, on one of these days, I don't remember which one, Jupiter actually occulted Neptune. I don't think Galileo saw that event happening, but you know, here's sort of a missed opportunity. In 1612, 1613, wouldn't it have been great if Neptune was discovered as well as the moons of Jupiter? That wasn't to be, though. So let's take a little bit more of this timeline here. Go down it. Go into the 1700s. Not much happens with Neptune then. But Uranus was discovered, so that everyone was happy with that. Neptune wasn't known about yet. And then finally, in mid-1800s, Neptune was discovered, quickly followed by its large moon, Triton. Again, we had another moon, Nereid, discovered by Gerard Kuiper. Of course, the famous Voyager 2 flyby, which took some excellent, fascinating pictures, sent them back to us, which just really sparked a lot of people's imaginations on what it's really like that far out. Then finally, a few years ago, 12 years ago, 13 years ago, Neptune had made its first orbit of the sun since it was discovered. It just shows how far out and how long its orbital period is. Now let's talk about how to find Neptune tonight or in the near future when you can, when it's not cloudy. It is cloudy here. So how to find Neptune? Well, first you locate Pegasus, find the circlet, which is the ring of stars of Pisces right below Pegasus. Then you take draw a line from the top star in that ring, which is Theta, to the star on the lower east side of the ring, which is Lambda. Continue that line for the same length, and it lands on just about where Neptune is. So in a way, it isn't really hard to find. You just have to have a detailed star map to pick out all the extraneous stars and zero in on Neptune, which is what we're going to do. I have a one degree field here represented, 7.8 magnitude Neptune, and then some other field stars around it. That's kind of what it looks like. It does have a little bluish tint to it, but it looks almost star-like. But if you look close enough and really pump up the magnification, you'll see that it is a little disk. And that's all you're really going to see with a small amateur telescope. You might be able to see its large moon Triton. You might not. So looking at this, I started thinking, well, gee, I wonder what it's like out where Neptune is. So I thought, well, let's go there and see what happens, see what we can do. So we're going to fly 2.7 billion, I believe, 2.7 billion miles out to Neptune. What is it like out there? You have the blue Neptune and its large moon Triton. Triton is a little bit smaller than our own moon, but in Neptune's sky, it's about the same angular diameter as our moon. Well, if you're orbiting around low Neptune orbit, so to speak, looking out in the solar system, what are you going to do? Are you going to see all these planets? Or are you going to see Saturn and Uranus and Jupiter and Mars and all this stuff? Well, the short answer to that's no. You might be able to see Jupiter, but you're looking towards the sun. It's not far, angular distance far from the sun, but it does have a fairly bright magnitude of being 2.5. It's nothing like the minus 2.5 that it is in our skies. So well, you might be able to see it, but you are looking towards the sun. But Saturn and Uranus are below 6 magnitude, so you really aren't going to see them. Triton you'll see, but it'll be a dim object really, because that far out, it only receives 900th the amount of light that Earth does. So you can imagine that small amount of light reflecting off the moon, off Triton in this case, it's just going to be pretty darn dim. Let's go back to this plot again. Again, you have Saturn being closer to Neptune. In fact, well, I'll just leave it at that. Saturn is the closest for right now. Let's look a little bit about brightness out there, since I just mentioned that it's only like 1/900th the amount of sunlight falls on Neptune as the Earth, as we get on Earth. Well, on Earth, the sun is at a magnitude of minus 26.7, obviously pretty darn bright. But as you get towards Neptune, farther from the sun, its brightness decreases. So Neptune's minus 19.3 magnitude, which is again about 900 times dimmer than what we would see of the sun from here. Continue down the scale. Well, you got the full moon up there. That's our full moon, about minus 12.6, first quarter moon, and so on. Triton at the full phase is minus 7, which, as you can see, it's about 200 times dimmer than our full moon. And Triton at crescent's even more dimmer. A bunch of stars in there, with which you all recognize from Arcturus and so on, Polaris. Its next biggest moon, Nereid, is a magnitude of 2 at its maximum. But it's a lot smaller than Triton. I think it's just a few minutes in arc minutes in diameter. So you really aren't going to see it. And then, because Jupiter's 2.5, and there we go, Saturn and Uranus, really 6.8, 6.9. You aren't going to see them. So you have these things out there which are just so dim. Poor Neptune's alone by itself. And that is why it is indeed a lonely place. Thank you.
Very good. Very good. Thank you, John. I love all the illustrations that you always do.
Yeah, well, sometimes I even like making them. Sometimes sometimes I'm wearing a hat because I pulled all my hair out in some of those, but yeah, it is kind of fun making them. And I hope that they do get the point across, because my real point is to make you think. That's what Scott Harrington was saying. Observing is really just as much with the mind as it is with the eye. And it's always nice to have an idea of exactly what you're looking at. And I guess you can see so much more if you kind of know about it beforehand.
Sure.
So I appreciate you bearing with me and all that. And I hope we won't have a cloudy night so we can go out and try to find it.
Right, right. Well, and I want to give a shout out also to the Astronomical League. If you watch Global Star Party, you'll notice that the officers of the organization show up at every event that we do. And Global Star Party is as much of a Astronomical League event as it is for the Explore Alliance. So I really appreciate all the participation that you guys do.
Oh, thank you.
I know it's not always easy to make this time. So very, very much appreciated, and love what you do, John. So I'm a big fan.
Well, one
Same
thing
here, John.
Oh,
This is Adrian
that's
checking
Adrian.
in on the road.
Okay,
I
Adrian.
plan to be at Alcon at Bryce Canyon with my camera.
I'll meet you there. I'll meet you there. But Scott, one thing that I just wanted to add to this is something that you do, that you had just said, that what I like, and I know what the officers of the Astronomical League like, is that you encompass such a great expanse of astronomy. It's just not talking about Neptune. It's talking about philosophy. It's talking about some poetry tossed in, talking about what it means to people, talk about the whole facet of how Cloudy Nights fits in.
Yeah, there's so many aspects of amateur astronomy, and I know that's why that sustains all of us, I think. So
well, remember, astronomy is just not a bunch of people standing off reciting facts and figures, distances and brightnesses and masses. I don't even do that because I think, well, gee, I don't understand what all that stuff means. but it's a lot more to it. It's a lot more personal, and it's a lot more worldly too. So
Yeah.
I'll shut up with that. So
No, it's
No, I
all
was
good.
gonna back that up because we had an interesting exchange at Alcon last year during after the Artemis discussion. I'll go on camera. All you gotta do is see me driving. Um, during the Artemis discussion, the mission, um, someone came up with a question: why should we go back to the moon at all when there's other stuff to deal with here on Earth? Came kind of out of the blue. I know I responded to it. We choose to go to the moon. It kicks off an interesting discussion. A lot of different aspects, I guess, different things surrounding astronomy can come up at any time at one of these conferences. And
yeah,
I'm
it's
sure,
nothing wrong with expressing such sentiments, because you're with
right?
other people, very knowledgeable people, and you just might learn something, and they may learn something
Yeah,
from you. So
yeah,
They were asking those questions even before we stepped foot on the moon. You know, should we be spending this money to put men on the moon as we did with Apollo 11? You
Sure.
know, and we went back again and again.
Yeah.
You know,
Well,
part of it,
I can think of a lot worse ways to spend money. I'll tell you that.
absolutely,
so can I.
absolutely, yes. So, but the payback from all of our exploration and efforts to build the technology that got us to the moon and back has paid off big time and continues to do so. So,
Agreed. Agreed.
yeah.
Yeah, I would agree with that.
All right.
So, yep, I'm near my destination. I will stop by Jackie Star Party just being on,
Okay.
but I'm at the Okie Star Party. I'm actually going. I have a connection with Kelly Ricks, who's been on Global Star Party.
Oh,
I am
okay.
going to image from Capulet volcano tonight,
Very good.
so I'm
Very
looking
good. Tell
forward to
Kelly
that.
we said
And I sent the picture of
hello.
the comet and the crescent moon. I think you got that.
I will look
So
for it.
let
Thank you.
me go back on mute, and the program can carry on.
All right. Thank you. And thank you, John. Thank you. All right. David, I'm going to bring you on and we can talk about the Cloudy Nights community, and Mike Beeler, who is heads up Astronomics, but also makes it possible to have the community of Cloudy Nights. It is, I think, by far the largest online community of amateur astronomers. Any subject that you want to know about, or any piece of gear or different types of gear, how it's used, a great place to go is the Cloudy Nights Forum, which is at cloudynights.com. I'll put the link in the chat here. But Michael Beeler has agreed to be on tonight to talk about this a little bit. Mike has been in the telescope industry, the amateur telescope industry, and also serving amateurs and professionals for over 40 years. That's it's wonderful that someone like Mike has stayed in for so long, serving all of us with all of our questions and all of our needs and our desires. I'll tell you from experience that sometimes it's not easy to give amateur astronomers the gear and the expertise that they need to accomplish some of their goals. But Mike has put telescopes and telescopes accessories in the hands of many, many thousands of astronomers, and has not only made their dreams come true, but has made made I don't want to say this, a woke community. Can I use that term? Anyways, Mike, thanks for coming on to Global Star Party. Do you want to add anything to that, David?
Yes, I do. I want to say to Mike that I've been a bad boy because I've never been much for forums. I haven't participated. But I would like to tell you now that as soon as I get back from an appointment that I'm about to go to, I'm going to log into Cloudy Nights, become a participant, and enjoy the Cloudy Nights. Because having met you tonight, having experienced some of your wisdom before we went online, I can't wait to do that. Thank you.
Excellent.
Well, I don't know about wisdom. I appreciate the kind words. I'm just a dude here in Oklahoma doing what I have to do. So that's all right.
Very
Thank you.
humble. Very humble. Yeah. But
What
thank you.
what part of Oklahoma? I'm in Kenton or near Kenton for that star party.
Oh yeah, we've been in Norman, Oklahoma since 1979. So we are right south of Oklahoma City.
Okay.
Yeah, not quite Panhandle, obviously out in the darkness of dark. But yeah, no, we're just here selling, shipping, helping, doing, being. So
and really one of the great telescope outfitters out there in the world for sure. All right, well, we're going to turn this over to you, Mike. Thanks for coming on to our Global Star Party with the theme of Cloudy Nights.
How appropriate could that be?
Perfect.
It is perfect, I guess. I mean, it's the thing about Cloudy Nights in general is that we all have to find something to do with our time, and we can't always enjoy the hobby that we like in the manner that we want to enjoy it. So we won't always be able to be out imaging, observing, even talking to local astronomy club members or people and sharing the passion that we have for this sort of thing. So Cloudy Nights serves a very distinct role in community. We have a lot of astronomers. It's a solitary hobby. It is not something that garners large groups, so they need a place to congregate, and Cloudy Nights allows like-minded individuals to come together on an extremely large worldwide basis and share their ideas in some people say overly moderated forum, whatever. Our mods and admins want to keep it friendly, push it forward, not get into political debates. We want to stay on topic. We want people to find the information they want and never feel like they're being belittled or demeaned. I mean, it's not going to be your Reddits. It's not going to be some of the old Yahoo groups and that sort of thing. If that's what you want, Cloudy Nights is not for you. But if you want to learn and make friendships with people that you would never, ever have met in your entire life, then Cloudy Nights is definitely a place to go. And we've got about 200,000 registered members.
Wow.
And we see 40 million visitors a year. And we'll do 400 million page views a year. And the average user spends about 10 minutes a session online. So they're reading, turning, congregating. Now, it's funny because with all the members, we have a ton of lurkers more than we have contributors, which is great. I mean, those are people that are learning. They don't necessarily want to dip their toes into the pool, but they're there to learn a little bit from the knowledge that's passed down from hundreds of thousands of people that have posted on Cloudy Nights and have lent their expertise to it. So it's been great. And whenever Alistair approached us originally, gosh, 20 years ago.
Yeah,
It seems like it's been
let's learn
forever.
a little bit about the beginning of cloudy night.
Sure.
Yeah.
So Alistair St. Clair started the Cloudy Nights. It wasn't a forum though. It was purely reviews. And he did it just, out of his garage essentially, because it just did it from his house. He'd sit there and type up, I'm going to do a review on a telescope. And then we're going to do some giveaways. And he felt the next step was to do a forum section. He couldn't afford to do the forums. It was just too, I don't know about too much money. It was a lot of time consumption because he had a special needs child. He needed to really spend the time with his family more than trying to run a board. I get that. I mean, I've got a child who's on the spectrum. So, I mean, I understand wanting to spend time with your family.
Mhm.
So he went and telescopes.com had shown interest in it. Astromart had shown interest in it, and he came to us because he was one of our customers, and he's like, look, if you can take care of this, then it would be great, and try to keep it as free to the community as possible, make sure that people can use it, and just we'll see what happens. I was like, okay. And we bought it, and we've tried to stay hands off. I mean, I stay at arm's length. We have 70 volunteer moderators and 12 admins, I think, right now.
Wow.
That all volunteer based. They spend their own time on the forum, hours on the forum, making sure everything works every day, 24 hours a day. And they do it for zero pay, zero recognition, and they do all the dirty work. I mean, some of our moderators actually they build the site. I mean, they are the IT side of Cloudy Nights. And we don't go out. I make no money off of Cloudy Nights, realistically. I mean, sales that come in, obviously, that helps a little bit, but there's no other funding to it. So I've got all these great volunteers that are willing to donate everything and help keep this community, because without any of the posters, any of the volunteers, anything, Cloudy Nights would not exist.
I want to interject something here, Mike.
Sure.
You mentioned that you don't make any money off of it, but of course you sell products. But I will tell you that everyone that is in the whole industry, let's just name a brand, any brand of telescopes, all the way from two guys working in a garage to, the top telescope companies out there around the world, they too benefit from this. And astronomy clubs benefit from it. Star parties benefit from it. So this large of a community is huge. And it's been going on since 79. Is that right?
So Astronomics since 79, Cloudy Nights, I think we're at 20. I think Alistair started at 21, maybe even 22 years ago right now. So that's when it started.
I mean, that is definitely what I would call commitment, so.
And I look, if I was in it for the money, I would be doing something else right now. I mean, I would, and that's fine. I enjoy this. This has been in my blood. Yeah. I've been doing this since I was 7. And Cloudy Nights, as long as it can help keep the hobby going, and not from personal gain, but just to keep the hobby going so everyone can enjoy the passion that people get when they discover a telescope, they discover imaging, they discover community, they discover this group, then it's a win. I mean, it's a win across the board for everybody. So I don't know. I am shocked it's gotten as big as it is. I thought maybe with the comeuppance of Reddit that we'd see some traffic die down. No, it's still growing, still getting bigger, still seeing lots of traffic, still seeing lots of people. So it's, I'd like to say there's a lot in store for Cloudy Nights, but I mean, how much in store can a forum be, right? I just want people to enjoy it, use it, and grow it naturally and get involved. So
Well, all the help that comes from the users of Cloudy Nights is tremendous. I mean, where else? What other hobby? I mean, if you get into diving, is there a community of 200,000 divers that are going to get on to, maybe,
who knows, right?
Perhaps, but I think that amateur astronomers are some of the most sharing people that there are.
Well, and when you go to Google and you look for something, you'll find, if not the first, maybe even the first 10 comments, you'll see Cloudy Nights scattered through there with answers to your questions. I mean,
That's
it's just, it is indexed like crazy. It has information out the wazoo dating back for 15 years worth of forum posts, and then 20 years worth of reviews. I mean, there is a ton of information, and we would love to have more reviews. We would love to have more people turn in reviews on their equipment, but I think a lot of people are afraid that their writing skill isn't this, or they can't do that. Well, contact us. We have editors that will help you get that sort of thing up there. We would love to have as much professional use from astronomers around as well, whether it's Explore Scientific coming on and talking about their products on Cloudy Nights. Celeste trying to set up a user base so they can talk about their new Origin scope. I mean, that's what we want. We want, I hate using words like this, a synergy between.
It's a good word.
I know, but I mean, it's like, here's my SAT words for the day. So we want a synergy in between the users and then the rest of the hobby that they may not get from trying to contact a customer support help, because that doesn't always work. Sometimes you need people in the field that have run into this problem. I've had customers who have asked me questions, and I'm like, I don't know how to help you. I've never run into that problem ever.
Mm-hmm.
Someone on Cloudy Nights has the answer for them, which is awesome.
Right.
So awesome.
Occasionally, Mike, I travel to Asia and will talk to the manufacturers there, and they will recite reviews on Cloudy Nights, when they're trying to develop a new product. And so it's on so many levels, that maybe an amateur astronomer wouldn't see. Cloudy Nights is supporting. But Astronomics pays the bills of Cloudy Nights, and you have for a long time. So you should be given some sort of Academy Award for supporting the community in the way that you have. And so it's wonderful. It's free. It really creates the tone and texture of what amateur astronomy is today. And so if you don't belong to Cloudy Nights, you should definitely join.
Oh, for sure. You don't know what you're missing until you get there, and then you realize what you've been missing.
Right. So, Mike, what have you seen? Have you seen any kind of milestones that have happened over all these years with Cloudy Nights? Anything that you might want to share?
I mean, and this is me being just ridiculous in it. I literally try to keep my nose out of it, because I have a lot of people like, oh, hey, you're just using Cloudy Nights to push your agenda. And that's not what I'm doing. So I try to just not keep so involved in it. I'm super arm's length with it. I was shocked the other day when I logged into the back end and saw we were approaching 200,000 registered users. It seemed like just last year we were at 100,000, which I know isn't the case, but time flies and I lose track of time. So, but it
is true that the community at large of amateur astronomers is growing. We see membership growing in the Astronomical League. We see, it is the interest in looking up and trying to understand where we are in the universe is evergreen. And and for whatever reason, things that have gone on this planet, it's creating intense interest, and so, and I'm grateful that that Cloudy Nights exists.
I am too. And with this next batch of kids, and I can see it in my kids who function on their computers or on their phones. I mean, it's not a lot of in-person meeting a lot of times. That's where Cloudy Nights will help them. That's where Cloudy Nights is going to be where people go, just like these smart telescopes are the next revolution of the way astronomy is working. So I hope we see an influx in here. I think the death of astronomy is greatly exaggerated. And I believe that it's just going to keep growing and people will get back into the hobby where it is enjoyable with a group of people, whether it's in person or on the computer. I think it's going to be leaning more towards computer. And I think Cloudy Nights will be there to help them get along in a safe space, whatever you want to call it.
Safe space.
I know. But yes, a place where they don't feel judged. So that's
a
non-judgment zone. So
right, that's true. So, and some of the things I love to read in Cloudy Nights is when you've got a real newbie that's coming on, and you can tell they're a little timid and they go, I just want to ask this question, and they'll be asking a question. Maybe they have a small telescope or something, or a telescope they found in a garage sale or something like that, and they want to know how to get involved in it. And I love it because I know that if they stick with it and start to learn what this community is all about, they're going to stay with it probably for a lifetime, and so if you are someone that's on one of these threads that's on Cloudy Nights, thank you to all of you that have encouraged people to learn more about this lifestyle that we have, to share, all the goodwill that you guys, dish up.
Yeah, it's just awesome when someone asks a question that may have been asked 100 times,
exactly,
and you don't get a point or two.
Times.
Well, that question's been asked and it's answered over here, like a lot of forums that I get involved in. People will take their time. It may not be as long a thread or as long as a discussion, but you'll get people that'll take their time. They'll answer the question politely. They will treat them as an equal, and they'll give them the information they're asking for without being snarky or a pain.
That's
so, and that's awesome.
That just doesn't happen. Outreach part of Cloudy Nights, people that do educational public outreach, they're very used to being asked a question 1,000 times and answering it 1,000 times without saying, oh no, here, if you were standing on a street corner and someone asked you, can you see the flag on the moon with your telescope, and you just handed them a piece of paper saying, I'm tired of answering that question. Here's an explanation of why you can't. Okay. But no, they'll explain. And that is part of caring, tenderly for these people that are trying to learn how to explore in a personal way, so.
It could be the largest astronomy outreach organization in the world, hypothetically.
I would definitely say that.
If you want to put a tack on it like that, then that's kind of where it falls into at this point.
That's right. That's right. Well, great. Well, wonderful. Well, Mike, thank you so much for on tonight. If there's anything that you want to end with here, it's wonderful to have you on. You've been on before, and we're glad to have you back.
I just appreciate you doing this sort of thing, because it's not like there's a ton of TV shows about astronomy that are out there right now. So it's nice that you're willing to get people all around the world, put them in this little box or in the phone in front of our hands, and we can get together and do life, because this isn't just sales pitches and commercials. I mean, it is just straight information and stories from
Yeah.
everybody that you would never hear. So this is really awesome. I mean, I appreciate the fact that you put the time and effort into doing
Oh,
this.
it's kind of selfish on my part because I love doing it. So thank you so much,
Um,
Mike.
Oh, no problem. Thank you, Scott. I appreciate it.
All right. Thanks.
All right. You all have a good one.
Okay. So our next speaker is Ron Breacher. Ron is the Astro Doc. And Ron, what do you got for us tonight?
Well, you know,
What
I
do you
always
do on
try.
a cloudy night?
Oh, I've been on cloudy nights.
Yeah.
In fact, I think I was on cloudy nights today looking for information about a Tribatanov mask for calibrating my telescope.
There you go.
So, yeah, I think any astronomer who knows where to look for information is going to find themselves on cloudy nights regularly.
Yep.
So
I
thank
would
you,
agree.
Michael, for doing that. Thank you.
Oh, no problem. I'm just interested in what's in the cases in the back because I have like 6 or 7 cases in this office I'm in right now. So
Did you see it? When you were talking, I was noodling. I've got a 1978 Martin D28.
okay.
I've got 4 Emerald guitars from Ireland, all carbon fiber. So I've got one electric, 2 acoustic, and a beautiful short scale 12 string acoustic
Okay.
with a mandolin voice.
I
Hold
was
on.
about to say, if
Hang on.
it's small, it's got to
I
be
can't talk
mandolin.
like that and not show it to you.
I appreciate it. Sorry, I just hijacked it. I apologize.
No, that's cool. That's cool. You know, we've had musicians. There's a lot of astronomers that are into music, and
Sure.
you know, so
Right, this is my
perform live.
little short
that
scale
beautiful?
12 string. It's all carbon fiber.
Wow.
Wow.
You can see inside the sound hole. All these guitars have this offset sound hole,
Right.
and there's the headstock. It's beautiful.
That thing is just massive. The headstock is half the size of the neck, basically.
Yeah.
So,
But listen to the voice. It's a mandolin voice. I didn't want to learn how to play mandolin.
I understand that.
Mandolin. Anyway, that's not what we're here for.
I understand. I appreciate you taking the segue for me, though. Thank you very much.
Okay, so Scott, what I have here, you know, I always like to riff off your themes. So what I'll do is I'll share my screen here and go to slideshow from the beginning. So I'm an astro imager, but I'm also a visual observer, and this talk is about essential imaging tasks for cloudy nights and sunny days. Boy, goodness knows we get enough of them. One of these days on the Global Star Party, I'll give a talk about how many clear nights you're likely to get as an imager in your lifetime. And hopefully it doesn't hurt your business, Scott, because it can be kind of depressing, especially if you don't make every bit of use out of that time. So Right. So I use the cloudy nights and the sunny days that we all get so many of to do a bunch of things related to astronomy. And although a lot of these tasks pertain to imaging, they also can pertain to visual observing. And so there's something in here for everybody. So like I said, I like to riff off the theme. So I'm going to talk about that. And then I'm going to talk about how I make the most out of cloudy nights. So I collect calibration frames, and I can't go into the details of it, but at my website, astrodoc.ca, you'll find under the articles tab one of my Sky and Telescope articles all about image calibration. I'm also going to talk about fine-tuning your equipment and other things that you can do. So Scott sent us this theme. I've highlighted in yellow some of the things that really stood out to me. First of all, this theme was inspired by David Levy, we were told. But it's an opportunity to explore the beauty, mystery, and inspiration, even when the skies are less than ideal. And I said we get a lot of that. And so, you can use your cloudy nights for discoveries, reflections, or shared moments. You can analyze your data, learn, strategize. But what I do is I get ready for the next clear night. So what I want to talk about here really is how can astronomers use cloudy nights and sunny days to get the most out of their clear moonless nights? And I've already talked a little bit about the details. So let's talk about calibration frames. So I said get calibration frames. Calibration frames are used to clean up raw images. So if you're an astrophotographer, the images coming out of your camera are going to look kind of like this thing at top left, very speckly. In fact, this is stretched to make it visible. The images themselves look dark with a few white dots on them where the bright stars are. And this is a close-up of this lower right corner. If you clean it up with the calibration frames I'm talking about, it can come out looking like this one on the right. And so what are those calibration frames? Well, there's darks. Dark current is builds up in a digital camera over time, and more dark current at higher temperatures. So we want to subtract that. That's where most of the speckling comes from. There's bias current, which is added to every frame electronically in the camera. And that causes these vertical lines. You see one right here in the raw frame. And then there's flat frames that you need. So all cameras are suffer from vignetting, cameras and telescopes. So pictures are darker at the corners, and you can also have dust spots and uneven field illumination. Flats fix that. And without getting into the math, look how effective it is. So this is an uncalibrated frame. This is a frame that's been cleaned up with those three types of cleanup. And in particularly, if you want to see the effect of the flat frame, look in the upper right corner, how it brightens up to reveal more of the nebula. And all the corners do that. So that's really nice. So that's image calibration. And I said I like to do this during the day or on a cloudy night. When you do it, what do you need to do? Well, you need 16 flats for each filter that you're going to be using, minimum of 16. And so if you're using a one-shot color camera, that's just 16 flats. But if you're shooting with a mono camera and 7 filters, well, you can do the math. It's a lot more flat frames, so 16 per filter. Then you need 30 dark frames that are going to match those flats. So try to keep all your exposure times the same for all your flats. I always shoot, all my flats are 5 seconds long, and I adjust the intensity of my light. So I only need one set of these dark frames to match the flats. And then my light frames are all 300 seconds long, 5 minutes. I need 30 of those dark frames to match the lights. And with that, I can get this beautiful cleanup. And this is just one single image. When you then combine a whole bunch of these, this might be a 5-minute image. When you combine hours and hours and hours of this data, then you can produce some really spectacular results. So one of the other things I like to do, and I definitely don't want to waste good imaging time for this, is tweaking my equipment. So there's a lot more that I could have included here, but in the interest of time, I'm just going to talk about 4 things that a lot of beginners maybe don't think about enough. Maybe sometimes they think about it too much. And the first one is cleaning. That's something I think people think about too much. The other 3, maybe not enough. So let's talk about cleaning. Number 1, cleaning needs to be infrequent. And number 2, it needs to be really gentle. Those little specks of dirt on your corrector plate or your lens They're not doing any harm while they're sitting there. But when you start moving them around, you can scratch the coatings. Now, the coatings aren't quite as soft and as some manufacturers would have you believe, but I would always rather have dust rather than scratches. I just cleaned my C14 this weekend. I hadn't cleaned it in 14 months, and it was filthy. The corrector plate was filthy. This image was taken in the week before I cleaned it. So, you may not need to clean every time you think you need to.
That's right.
Make sure you follow the manufacturer's instructions concerning what liquids or whatever to put on your optics. And if never look at your optics in a bright light, because it doesn't matter how clean they are, they'll look dirty. Really look at the pictures or the view through the eyepiece, and if it's good, try to leave those optics alone for another month or two. Balance. If you want your mount to perform properly, you have to balance it properly. And believe it or not, it's not just as simple as eyeballing it. Especially if you're imaging. If you're doing visual, you just need to get close. But if you're tracking for the purpose of long exposure astrophotography, there's a right way to balance your mount. And so what you need to do, you'll be using an equatorial mount most likely, unless you have a really, really fancy-dancy alt-azimuth plane wave mount or something with a field derotator, then you can safely ignore all of this stuff. But in most cases, you're going to orient the scope this way and adjust the balance in declination first. So that's moving the scope up, the front end of the scope up while the back end goes down until you get balance correctly, and then lock that axis. Then adjust the counterweights. That's the way to do it. You need to balance every time you set up. Really important. One of the things, I want to go back here. I meant to say, you'll notice here that the lens cap is off. You really have to do all your balancing with all of your equipment connected exactly as you will use it under the sky. So if you're going to have a dew heater strip like I do here, if you're going to have a dew heater strip on your telescope, it needs to be on when you balance your equipment. All equipment attached, all cables attached, lens cap off. Critical. And cable management really affects balance. So I'm sure we've all seen, and most of us have or have had, one of those spaghetti scopes that have cables dangling out every which way off of everywhere. See if you can figure out a way to manage those cables so that all of the cabling, or as much of it as possible, is above the equipment and not able to dangle down. So in this case, you'll see over here, some of the cable is affixed with some plastic cable tie. The cables are sandwiched or tied around, in this case, tied around the posts here. So, oopsie. We really want to try to manage those cables. If you don't, that will affect the balance of the mount that we just talked about as being so crucial, because as the telescope moves across the sky, the cables will be moved by gravity. That will affect your tracking and the shape of your stars. Make sure also that you secure your cables in a way that prevents them from getting snagged on some piece of equipment and you coming back to your rig in the morning and finding something in tatters on the ground. So that's all I want to say about fine-tuning equipment, although I'm going to come back to it later on. One of the most fun things to do when it's cloudy or during the day is to plan your next session. And this applies whether you're visual or an imaging astronomer. One of the websites that I really like is telescopius.com. astronaut.com. You can set up a free account there and enter your equipment. So if it's visual, you could enter your focal length, the eyepiece that you like to use, and your latitude, longitude, and it'll give you a list of objects and you can filter them. You can say, show me all the open clusters that are available tonight that are above 30 degrees between 10 p.m. and midnight. So very very cool resource, and we all have our favorites online, but this is one of my favorites. So plan your next session. Think about that in advance. Process your data. So this is a screenshot of another screen that I have open on my computer right now. I was doing, on a cloudy night last night, I was doing some collimation, and I had enough time to get let's see, 10, 20, 30 minutes of data on the Iris Nebula, and was just doing a test process before I came on tonight. So processing your data, you can do anytime. And, you can do some pretty cool stuff. Processing your data, by the way, takes about as long as acquiring it. So I might spend 40 hours over 5 to 7 nights acquiring images like this. And then I'll spend probably, I don't know, 15, 20, 30 hours processing it. That's not all in one chunk. And it's not to get exactly what you see here. After every night, I process what I've got. So I practice, practice, practice. And then by the time I'm finished acquisition, I'm ready to process it for real, and I can do it in a couple of hours. And the last other activity that you can do when you're not actually out at the telescope or working with your imaging is you can share this stuff with your friends. And this is really why most of us who are doing astrophotography, most of us are really blown away by the photos that we can take with our own amateur equipment from our backyard often. And we want to share it with our friends. So that's why we do this. And, posting it online on Facebook, or like I have a website, astrodoc.ca. By the way, I mentioned a little while ago, the articles tab has some really useful articles, not just for imagers, but visual as well. And so sharing is just a ton of fun. And there's even other things that you can do. Obviously, I didn't have time to talk about how to collimate your Newtonian reflector or your Schmidt-Cassegrain telescope. One thing you can do on a mediocre night, so this is a night where you can't image or see faint objects, but you can do some other useful things. So one thing is you can see how long you can guide and still get round stars, because that'll tell you an upper limit on the length of exposure you can shoot when the conditions are good. I don't care if you think your focals or your filters are parfocal. They're probably not. And it's useful to figure out how different they are and program that into the system, so you don't have to focus every time you change filters. Same with, as the temperature change, your focus position is going to change. If you can figure that out on a mediocre night, you can use that information on every clear night. A lot of mounts, especially if you have a permanently mounted telescope like I do, will benefit from a pointing model of a few hundred stars. Now, my Paramount acquires those automatically when I tell it to. It does about 5 per minute, so I can get a 200-point model in about 40 to 50 minutes, let's say. I can do that on a night when the moon is full and transparency is terrible. If I can see stars, I can establish a pointing model, and that means the next time I go out on a clear night, my guiding is going to be beautiful. My pointing is going to be precise. And obviously, polar alignment falls into the same category. Whenever I build a pointing model, the first thing I do is verify that my pointing, that my polar alignment is good. And if I need to adjust it, I adjust it before I establish that new pointing model. So I guess what I want to say is don't sit around moping about those cloudy nights and wishing it was clear. You'll make yourself crazy. And I can guarantee you it will clear eventually. Eventually.
Here, here.
So take advantage of the cloudy nights and especially enjoy the sunny days. Astronomy isn't just for the nighttime. So that's what I had for you tonight.
Excellent, excellent. Thank you, Ron. You know, if you are watching this program live, I'm going to recommend that you, especially if you're into astrophotography, that you come and visit this program again and watch Ron give all those amazing tips, because you know, this is a guy that he's truly a master astrophotographer, and you know, he does tutor. You know, if you want to take your astrophotography to the next level, the guys like Ron can absolutely get you there, and make great use of your valuable time. So, you know, if you think, oh, geez, I don't want to spend any money getting tutored here, think again, because you're worth it. Okay. And your valuable time is worth
It makes a
So,
huge difference. And, you know, you can come to me for one-on-one, just contact me through astrodoc.ca.
yep.
But if you want to go to workshops, or we have a subscription model, very inexpensive, at mastersofpixinsight.com. And we're not the masters. We're trying to make our students the masters.
Right.
We have hundreds of subscribers. We have 1 or 2 workshops a month, hundreds of little videos that are 2 to 7 minutes long to really get you going quickly. It's supposed to be fun.
Yeah. And it is.
Yeah.
It is fun. Thank you so much, Ron.
Thanks
Thank
for
you.
having me.
Yep. Yeah. And take care. Enjoy the
Yep,
rest
see
of
you
the
next
night.
time.
Yep. Okay, our next speaker is, we're going to go down to Brazil to talk to Marcelo Souza. And Marcelo, thank you for coming on to Global Star Party again. You are a very loyal participant, and you are on almost all of the Global Star Parties. You are also the editor of our astronomy magazine, our free global astronomy magazine, and called Skies Up, but it's about to get a name upgrade here. So, you know, we are very, very pleased and honored to publish all the articles that are given by contributors from around the globe, and to make it free. And so, it doesn't replace magazines like Astronomy Magazine or Sky and Telescope. That's not the purpose of it, but it is meant to give people access to a magazine that's written by some of the experts around the world, you know, that might not otherwise be able to get one. So you can find it on explorescientific.com/skies up. Marcelo, thank you for coming on tonight. And what's been going on in Brazil?
Hi, thank you very much for the invitation, Scott. Ever is a great pleasure to be here. Here in Brazil, in the spirit is very difficult the observation because we have fires in the forests. It is very dry here. Here in Rio de Janeiro, it's not raining for 3 months that we don't have rain.
It's a long time.
In many places in Brazil, more than this. Then it is you have the forest is dry. Then you have fires. And then during a few days ago, it was not here where I live, but in parts of Brazil was very difficult to see something in the sky at night. And when you talk about cloudy nights, I can say about my experience organizing events. We have the Murphy's Law that use in science, and I think that you have a law that you can use in astronomy that you have a directly association between cloudy nights and the importance of the event that you organize, the astronomical event that you organize. More important is the events. It's great the possibility to have cloudy nights. Many events that we organize, it wasn't possible to look to the sky because I have a lot of clouds. Last year happened this during the eclipse. I have a lot of people with I have thousands of glasses here, special glasses, so eclipse glasses to look to the eclipse, but it wasn't possible because also during the day we have the cloudy days, né? That didn't allow us to organize a observation of the solar eclipse, partial solar eclipse for us. Tomorrow we have another opportunity to see a partial solar eclipse, but very small part of the sun will be covered by the moon, but and it will be near the sunset, but it will be an opportunity for us. Then we are going to talk with the population, and I think that tomorrow we have a better, the sky will be with a few clouds, and I think that will be possible. But cloudy nights ever are bring problems to us when we organize events, but when after many years organizing events, we have options, né, when organize events if you have a cloud night, né? Because we know that it happens many times this, when you organize an important event and you can't look to the sky because you have a lot of clouds. And ever we have an option for this. Né? We organize during the night talks, we organize, invite people, né, to go to a different place, né, to know the equipment, to talk about equipment, to talk about the plans for the future, for the next opportunity. Then we can use it to talk about astronomy, and to make plans, and you have new friendships. Then we can use this moment for this. Then ever when we organize an event, we consider that the possibility to have cloudy nights is very high. Is directly associated with the importance of the event. When it's very important, you have more, the possibility is great, né, to have a cloudy night during the organization of the event. But it's not only the cloudy night that are problems for us. Another problem is what happened here last week that I will show you. We have now strong winds. The winds are stronger than in the past. Then these bring problems when we want to make observations and bring problems to the observatories. Then we have now two problems that you need to take care here. Is the rains and cloudy nights. Three problems: strong rains, cloudy nights, and strong winds.
Yes.
I will show what happened with the observatory last week. We had, I will share my screen. We had the winds with the velocity of 80 kilometers per hour.
Ooh,
80
80.
kilometers, 80 kilometers per hour. And what happened was this. Let me try to change here the screen. Okay. Here is the observatory. Now that's where it is located. We are using the telescopes of the Our Sky network.
Yeah.
That's you that you are responsible for. We have this partnership. Here is the observatory. Here inside the observatory, we have a roof, that protects the equipment and supported until 60 kilometers per hour. Everything was fine. But last week you have the strongest winds. And this is what happened. Here is the roof.
Oh, no. Oh, no.
Look where is the observatory. There.
Oh, my God.
I think that
That's
moved
pretty far away.
more than 60 meters far from the observatory.
Wow.
A
It's like
very strong
being
wind.
from an airplane.
That is the observatory. And
Oh, sorry.
here is inside the observatory. Everything was fine. The equipments are fine. Didn't affect the equipment. Only the roof that made a long fly. Uh, he, he- after in the morning when they measure, it was almost more than 60 meters, almost to 100
Good
meters
Lord.
far from the observatory.
Wow.
Here is the image in the moment that the roof left.
Wow.
It was a very strong wind. Then now we need to take care of this. And also we are having problem with the automatic telescopes that you use in the streets. The unistellar telescope don't work with winds. You need to go a place with very few winds, nice low, because if you have a stronger, not so strong like this, but if you have winds, didn't work well. And many telescopes now you need a mount that support this, and everything is changed. This is the image
Oh, boy.
of the roof.
Yeah.
It's not moving. Why? What's happening? Only a moment, my computer, I think that's not working well. Ah, now you can see.
There we go. Oh, it's broken. Yeah.
Yes. Here is where is located the engine.
Goodness. Well,
Now we are
replace that. For
building
sure.
a new
Yeah.
roof,
Yes.
and we hope that support the strongest winds. That soon, I don't know what will happen in the future, but you need to be prepared because each year you have a stronger winds.
Hmm.
Here's the equipment to show that everything is fine. After the storm,
Well,
the
it did its
telescopes,
job. It did its job. It sacrificed itself. So to
yes,
protect the equipment.
yes, everything is fine. But we were very concerned because never happened this. That's the first time that the roof had this problem. Now we need to protect, and we are trying to make it stronger enough to support winds that goes more than 100 kilometers per hour, because you don't know what will happen in the future. Because we are also waiting strong rains during the summer here,
Hmm.
because you have 3 months without rains. We don't know what will happen in the summer. That is the period of the rains here. Then here have to take care of many things, not only cloudy nights, but strong rains and strong winds
Yes.
that can bring problems for us. And I will show now images of some events that we organize in this period. This is in the same place where is located the observatory, that's Reserva Caruara. We organize an event every 50, from every 15 days. We have one event, 2 events per month that invite people to walk at the near the forest, and there we show the sky, show the constellations, tell histories about the constellations, and use the telescopes to show some objects of the sky, and also planets. Now we have Venus, Saturn. That's a special moment. But these events we had a cloud night. Then we walk inside the forest, but it wasn't possible to show the constellation. Then I have only histories. We talk about show Venus that was possible to see on. And yeah, we went to the forest. We have more than 20 people, most of them kids visiting the observatory or part of the observatory that we have now. And we go to a dark place. What's important because even we can't see the stars, we can talk about the importance of you don't have light pollution, that this can affect the animals. Then we can show animals at night, talk about the animals that need the night, like us. Then we can use these moments. Even with cloudy nights, we have events. And this is an event during the day, the observation of the sun. Tomorrow, we will try to see the eclipse. Here will be a partial eclipse, a very small part of the sun that will be covered by the moon, and near the sunset. But we know that many people want to see. We are going to give glasses, free eclipse glasses. We are going to distribute free more than 500 eclipse glass for the population.
Excellent.
We received it from Stephen Hammes, then from Charlie Bates, Solar Astronomy Project. And here, one of the events that we organized. So it's very hot. We are living here this way. You have a period very hot, then we have clouds, not raining, and it begins to be cold. Then you have a period that's very cold, then you have after this a period very hot, then and no rains. And then it was an experience of this, and then we organize it also in the public square, an observation
That's great.
of Saturn is what we like to do. We organize with frequency these events of the sky observation. And yeah, you can see we have a lot of people involved. People that walk in this public square, come with us to see the stars. And now we had, but I hope that tomorrow it will be possible for me to see the comets.
Yes.
I didn't see yet, but here in our city nobody saw because we had clouds since 27 September 27. That was when began the period for us to see the comets. But I have a friend in Argentina that took pictures, and I showed the pictures that he in 27. This is how appears if you are looking with a naked eye. It's like something like this. This is a picture. But he used the Alejandro Sommer from Argentina that took this picture and he authorized me to show. And he also authorized me to show here a picture of his friends that I show after this image. Here is with a camera, Nikon. At the same moment, he was in Posadas Misiones in Argentina, that is located in a state of Argentina that's called Misiones. Alejandro Sommer lived there, and he had the opportunity to see and he have these pictures.
It's a pretty short exposure, only 5 seconds.
Yeah, it's 5 seconds. Yes.
Yeah.
It's bright, but it's not because it's near the sunrise. For us, it's very near the sunrise because he begins at night after 4:30, you can see, but near the horizon. Then when the sun is coming, it's higher, but it is almost day. Tomorrow I will try to see. I will wake up very early to go there to see. And here are the fantastic images also taken by David Moyer also in Argentina, in Umaya, Argentina. That this is the comet that is possible to see here.
Really cool. That's a
In,
great image.
in Brazil, we don't have so many pictures because, as I said, you have fires, you have a lot of particles in the atmosphere. Then, in the beginning of the morning, it's very difficult to see in many places in Brazil. And here is a fantastic picture that I think. Because David Moya from Umaya in
Man,
Argentina also.
look at the length
And
of the tail. It's great.
yes, I think that after October 12 will be better to see. No?
Mm.
And it will be better for you that are in the northern hemisphere. For me here, I don't know. I will try because you'll be near the sunset. No? You have probably 15 minutes, 20 minutes after the sunset to see the comet. Then I don't know if it will be possible to see, but I will try. I will be there. If you have an opportunity to see, tomorrow I will try in the morning. And I will try also after October 12 to see if it will be possible to see something. And this is how will appear for us tomorrow, the eclipse. In Argentina, it will be fantastic, but I couldn't travel to Argentina to see the annular eclipse. But I will try tomorrow to see the partial solar eclipse here. But it will be near the sunset. Well, it will be near the horizon. Then I need to find some place that
Clear
here
shot.
you see the maximum of the eclipse. The sun it will be during the sunset. Here. Then I need to find a place here that the horizon near the west will be clear for me to try to see something there. But I'll try. I will be there tomorrow. Tomorrow I'll try to see the comet, take pictures, and see at night, the beginning of the night until the end of the afternoon, the eclipse. But I will talk tomorrow on the TV here. They invited me to talk about the eclipse, and because many people knows that you have an eclipse and you try to look directly to the sun. Right? Then this is a problem. I hope that this will be near the horizon, as you have a lot of particles in the atmosphere. This will protect them to look to the sun, direct to the sun. Right? I hope. But we'll try tomorrow. Then this is what I I prepared to talk today, Scott.
Wonderful.
And
Marcello, thank
let's
you.
let's see what will happen.
Yeah, thank you. We'll see what happens. And good luck on your interview tomorrow.
Thank you.
It's wonderful that you do so much astronomy outreach. I personally love to be on the street corner or on the street with the telescope and showing passerbys their first views of Saturn or the moon. And you get into so many interesting conversations, and it's just fun. It just kind of rejuvenates me, and makes me realize, that this is why I love what I love, so to
It's
share.
wonderful.
It
It's
is.
what I like to do, and something that we do here that people like because ever when a person looks for the first time to Saturn, you say that now it is a baptism for astronomy.
Ah, good
I
way
say
to put it.
now,
That's a good
yeah,
way to put it. Yeah.
now it's a baptism to astronomy. Now, it first when everybody when see for the first time, you talk with them and make a short ceremony. Say now we are. I don't know how to say in English, but we call a baptism here in Brazil.
Baptism,
This
same thing.
baptism, the same
Yeah.
that you use in church.
Yeah,
This is
same thing.
baptism for astronomy. About them.
Wonderful. Well,
Thank you very much, Scott.
thank
Always
you,
a great
Marcelo.
pleasure to be here.
We'll see you next time, and I'll try to catch up with you
Thank
around
you, Marcelo.
the
How are you?
12th.
Hi, sir.
Oh yeah, let's bring Caesar on here. So Caesar
Hi,
is in
Caesar.
his hotel room, and he's getting ready
Yes,
to do eclipse
in the
too.
lobby on the hotel, in the lobby of the hotel, and we are arriving at maybe 15 minutes ago. The Puerto San Julian is a small city and it's totally full of the occupation and hotels and homes, and we arrive from 2,500 kilometers from Buenos Aires. I can
By
show
car?
you
By car?
by car, totally by car. Yes.
Wow. Wow. Argentina is a very big country.
Brazil too.
Yeah.
Yes, and Brazil more. And yes, and South America that we have the long distance is normal for us, and really well, many people is going driving to Rio de Janeiro from Buenos Aires or Florianopolis especially, and we go to the sometimes we to the beach places in Brazil. We love go to Brazil, especially in summer. And we went here to Patagonia. We are in the maybe 92% of the ring, and maybe we can move again 50 kilometers to the north to have maybe the center ring, but maybe we can enjoy from here a little, and center ring is okay, but
But what is
we are in the place of totality, but it's annular eclipse, of course.
what is the weather prediction?
The weather prediction or the prediction for the
No, the weather prediction. The weather prediction.
I think that is 98. I think here.
Will be clear. Will be clear tomorrow.
Yes, but as you are, you have, sorry, the longest distance for the moon, and you have a thick ring, a thicker ring, comparing from the last annular eclipse from 2017, where we have ring of fire more more thick, more yes. But now you have a bigger ring. With more, yes.
Thicker, a thicker ring. Yes.
A thicker, yes.
Because the moon is far from Earth.
Yeah.
Now, yes, we are in how do you say in English? Pedro, in English is la posición es afelio, no, perigeo. In English is perigeo. And yes, the closest point, yes, and no, the closest, not the longest. Now the moon is in the longest distance, and you have a smaller shadow,
Apparent size, smaller apparent
silhouette
size
of the moon, and well.
But it is wonderful. I would like to be with you.
Sorry that I can.
Me too. And all of us, for sure. So,
I would like to be with you, to see the eclipse.
Can you hear us okay, Cesar? Can you hear us? I think he's losing his connection. Anyways, remarkable that he was able to get through to us from his location. He said he's about 2,500 kilometers away from from Buenos Aires right now. So
Ah, it's more
Yes,
than
I
this.
can show
oh, he's
you.
back.
I can show you in the map where it is. Yes.
So how many people
Uh,
are in your group, Cesar? How many people in the group?
Maybe do you have here? You can see my screen. No,
Not quite yet. Give it a moment here.
now.
No, it's sharing.
Here we go.
No.
Okay, we're good.
No.
Yes.
You
Yes.
can show it, you can see the map.
Yes. We see it.
Let me try again.
No. We
But
see it.
my connection is too unstable for my group is around maybe 50.
Yeah, we could see the map. We could.
Okay. I show you the map again. Now here. Now you can see the map.
Yeah, give it a moment.
Yes. Well, we are here, and we went to the south. More here. You can see the map.
Right now, no, we cannot see it. Oh, and we lost Cesar. Oh, too bad.
I think that he has problems with connection.
Yes.
Yeah.
Yes.
He's at
But
the hotel.
He Cesar has shown us remarkable things. We got to watch a total eclipse of the sun one time from a very distant location, and he was just using his telephone connection to make it all work. But it, the important thing is, Marcello, is that he always tries.
Okay.
So oh, I think he's back on now. I think I see him.
Caesar. Maybe its connection is very low.
Yeah, maybe. Okay. All right. We're going to go to a presentation.
Okay.
There he is. Okay. All right.
Okay, the connection is too unstable to maintain a conversation, but well, we see you. Maybe I'll send you tomorrow
Send some
image
pictures.
of the eclipse.
Okay. Good luck.
Okay.
Good luck, Cesar, and good luck to you, Marcello.
Okay.
Okay.
Thank you.
Thanks. Thank you. We are going to, we have a presentation from Kareem Jaffer from John Abbott College. Kareem has been on Global Star Party many times. And I met him along with a partner in crime and astronomy outreach. The Montreal Center for the Royal Astronomical Society of Canada is extremely involved in outreach, and we're really happy to have his presentations, and often he's able to come on live. Tonight he had another obligation, but he did pre-record this presentation, which I'll run now.
Hi, Scott. Hi, David. Hi, everyone. It's great to be back with the GSPs. I'm sorry I can't be with you live. I'm on my way to an event in Quebec City. But I wanted to take this opportunity to chat about cloudy nights, because cloudy nights in Montreal is a big thing. We kind of joke about the Montreal Nebula, this bank of clouds that we always deal with whenever we're observing. And it really is a part of our life here. So I'm going to share a little bit of that with you. But before I start, as always, with the Rask Montreal Center, we like starting with a land and sky acknowledgement. We not only acknowledge that we're on unceded territories, but also that we share the night sky and we share the sky itself with the First Nations people and Indigenous peoples, Métis, from all over the world and ancient cultures everywhere. Right now, we are at the very end of the September moon, the harvest moon that we talk about with the settlers, but the Mi'kmaq call it the mate calling time. And we've seen and heard the calls of the mates. We've seen moose rutting their antlers, trying to call the mates and be prepared to have their gestation period over the winter so that in the spring they can give birth and have their offspring ready for the following winter. In fact, the next moon that begins just tomorrow with the new moon is going to be the animal fattening time. So we're going to be seeing some of these animals, these indigenous creatures, starting to prepare for the winter that comes in the Northern Hemisphere. At Rask Montreal, we have a bunch of upcoming members events. We've been doing some interesting Wednesdays. We've been doing astrophotography workshops with David Schumann, our vice president, and moon gazing nights with our members liaison, Nicole Laporte. And we also have a couple of library nights coming up over the next 2 months and a movie night because it's fun to share our sci-fi love of space with, our love of old movies. There's some interesting ones coming up, including 2001: A Space Odyssey, which will be fun. And then we're trying to get out for some observing nights, especially with the comet coming into our evening skies soon. Knock on wood. Comet C 2023, T Atlas. We are really hoping to get a chance to see it. And then today I was reading about this awesome sungrazer comet that's coming through as well that we have a chance to see. So there's definitely some reasons to get out there and enjoy the night sky. Our upcoming public events, we just had our Townsend event, which I'll mention in a moment. We do have a wonderful event coming up at the end of October, which we do for young kids and families. It's Spooky Nights. It's run by our John Abbott College Space Club that I mentor. And they do activities in the early evening, Halloween themed, but space related, so that we get to share again our love of space and all things space exploration with these young kids. We're currently planning an online event with David to share his 100+ eclipses that he's observed and the 30th anniversary of Shoemaker Levy 9. And then we also have our December Geminids meteor shower that we're working towards. We just had this past Saturday our keynote Townsend lecture. Now our Townsend lecture has featured speakers from, it started with Harold Shapley and Carl Sagan has spoken, David has spoken a couple of times as our Townsend lecturer. And we've been really focusing on some of our local talent. And so we were really happy to have Jonathan Gagne. He is a researcher with the University of Montreal, a prof there, and he's the science consultant for our local planetarium. And he's working with the Gaia data to map out the young brown dwarfs and young stars in our local galaxy neighborhood, the Milky Way. And so he shared with us a little bit about what they've been discovering, the way in which they do the aging of these stars. And it's really fascinating to see the amount of information they're able to collect from the spectra and the radial velocity data from Gaia. So that was a lot of fun. And if anybody wants to watch our YouTube, it's on our Rask Montreal YouTube channel as well. Now tonight we're talking about cloudy nights. And I've made this mention before, and I have the picture of our solography that we took for 6 months here in Montreal. And you can just notice the number of sun paths that are blocked by clouds. And this is daytime, and normally our daytimes are clearer than our nights. Even on the clearest of days, you've got some patches of clouds that come through most of the time here in Montreal. We did get lucky, occasionally in the summertime with long periods of clear days and clear nights. But most of the time we are dealing with these clouds because we are surrounded by water. We are part of the St. Lawrence Riverway, and a lot of clouds follow along the waterfront here and pass through the Montreal area. In fact, this past September, when we did the lunar eclipse viewing just a couple of weeks ago, we were really looking forward to it, really planning, and the forecast was partly cloudy. The nice thing is, though, with the full moon is you can see it through the clouds most of the time. We got out on the field and we got to enjoy having everybody spread out on the field. We had 12 different telescopes. We had over 100 people there that night, over 70 students. But you can see the clouds were constant. We could see them, could enjoy it with the telescopes, but a light layer of clouds running in front, running interference the whole time. The interference of the clouds made for some really spectacular effects, especially through the eyepiece. And so we had two young women come and join us, high school student and a local visiting student. They got this incredible picture of the full moon with the wispy clouds through one of the telescope eyepieces. And so thanks to Annie and Julie for sharing the picture with us. Even during the actual small umbral shadow phase, one of my students, Lily, running a telescope for the first time that night, she ran it the entire night, a Nexstar 8SE, and she got beautiful pictures of the full moon as well as of the umbral phase, and that little, 8% coverage of the moon's surface, you still could see the wispy clouds around it. My daughter Tara was playing around a little bit with her telescope. She was taking images with the DSLR that she's still working on processing some of those a little bit more. But with the smartphone through the eyepiece, she got some nice views, and then she was able to process them to get much more detail on the moon. And I just love the fact that even with the smartphones, as long as you use the eyepiece and smartphones, you can catch the clouds, you can catch the features of the moon. You do get a little bit of that color distortion, but you expect that when you're really just kind of roughing the imaging part of the process. Going back a little bit further, when we had the waxing gibbous, we were out for International Observe the Moon Night. And it was coming through the trees and through the clouds. And so I made this little video recording so you can actually see the clouds and the tree branches as the moon passed through our view. And this is, the clouds are persistent with us. And I don't know what other way to describe it except that it lends its own beauty, its own ethereal nature to some of our photos. This is one of our students, Loic Janvier from our astronomy class this term, who caught the relative conjunction of Venus with the waxing crescent moon just a few weeks before that. And in fact, I went back through my files and I saw that the previous conjunction of Venus with the waning moon back in November, when they were really, really close together, November of last year, we were able to get this image, and you can see that it's entirely through the clouds. But you can capture Venus nice and bright. You can even see slightly that gibbous shape that we had in that early morning with the waning crescent moon. Now, this past summer, my daughter and I went to Momagantic Observatory to help them with their Starfest and to set up a telescope to share the views. And the day looked somewhat promising initially, there were clear spots to the skies. And as the sun set, we started to see these incredible, huge, thick clouds come through. So we still set up our equipment. We got ready. We were a little bit actually drenched just with the moisture at that high altitude. But the sunset was just absolutely phenomenal. But you could see just these beautiful textures through the sky, the cloud formations, the sun coming in and out of layers of the clouds. And then once we had the actual crowd that night, we were able to pull in a fair amount to see just a couple of targets. And up above us, there was a clear sky window. So because our Momagantic Observatory is known for the spectroscopic data, I always take my my RSpec filter with me. And so we got this beautiful filtered image of the spectra of Vega directly above us. And we had a 10-minute window where we were able to grab onto Vega, get the filter in, show the spectra to a crowd of 20 people, and that was it for the night. That was all of our observing for the entire weekend, actually. That's all we were able to see. Back in May, we were blessed with some incredible aurora, and we did an event afterwards where everybody shared their pictures of the aurora. And there was this bank of clouds that you can see here that just followed through every single picture. It was just moving through our view as the aurora did. And it kind of led this connectivity to everybody's images with each other, which was just wonderful to see. Going back to the total solar eclipse, April 8th, 2024. You can see the amount of clouds in the sky, but even with the clouds, the eclipse phases were beautiful to witness, and the halo of the sun through the ice crystals in the upper atmosphere. And then when totality hits, we were able to see that beautiful corona even through the clouds. And it was a little bit difficult to capture, but we were able to get a lot of it, which was just wonderful to see. Mars occultation last, well, two years ago in December 2022. Again, it was through the clouds. And because it was a full moon occultation, we had such an amazing amount of light that we captured multiple images before, during, and this is just after Mars peeked out from behind the moon. We had a lunar eclipse just before that, and the total lunar eclipse, we captured as many of the phases as I could that early morning down by the riverfront with a huge cold wind. It knocked over my DSLR camera like 3 times, which thankfully no damage at that time that I could tell. But as we were enjoying that, the clouds kept coming in and they kept obscuring. There was even at one point where the clouds kind of took over, and for a while I couldn't see the moon at all. And this is the moment just before that. So the cloud's thickness varied quite a bit that night. And my wife was watching through the windows at home and managed to catch an opening between the windows when the full umbral shadow seemed to be on the moon. And we got this beautiful blood red moon that night. The summer during the COVID, when we had the incredible annular partial eclipse visible for us, we went out to the waterfront to catch sunrise with the eclipse already happening, and you can see the clouds through every one of these pictures. But honestly, it was windy, it was cloudy, but it was incredible because you could see more features. And even if there were only a couple of sunspots, but watching them come in and out of the clouds became kind of a game to see how they came through. And when you use the clouds and you use something like photo pills to really plan your photo, our RASC current head for our national office, Jenna Hines, got this picture in Toronto. You can see the clouds, you can see the annular moon, and you can see the CN Tower. And it's just an incredibly gorgeous picture that she managed to capture. This past year with the students, they've really been taking a lot of images of the moon for part of the Globe at Night work that I've been having them do in the moon sketching. And so one of the things that they asked is how can they stack pictures? And I saw the quality of some of their pictures, and they're a little bit grainy. There's a lot of cloud formation going in and out. So I went back through and I found from October 2020 a group of pictures that I had taken of the first quarter moon and the clouds moving through the view. So I just want to show you a few of these. So there's 9 of these pictures, and you can see the clouds moving through. This isn't happening as smooth as I was hoping. From the International Observe the Moon night. And then I decided for the first time that I wanted to try the mineral moon. Now with GIMP, it's different than with Photoshop, because with Photoshop, you can work with the luminance as well as the saturation. In GIMP, there's no direct luminance function. So you have to play around a little bit with the temperature of the image, you have to play a little bit with the saturation, and you have to work a little bit with the brightness contrast levels as you play around with the saturation and the intensity of the saturation. Anyway, it took a long time, but I was thankful Roger Hyman from the UK was giving me a little bit of advice in my early stages, and I managed to get the mineral moon where you could really see the titanium-rich areas of the mares, and you can even see a little bit of the reddish-brown hues showing the iron-rich regions. So this was my first mineral moon, and my daughter actually was the one who had brought up the idea of mineral moons. I'm waiting to see what she ends up putting together for her first mineral moon. And then I'll play around with this a little bit more and maybe create a second layer to that moon lab where they start with the rough images and then they can play around with a little bit sharper. So again, cloudy nights is something that we work with all the time here in Montreal, and I don't think that's a bad thing. I think that's actually, that brings us to a little bit more creativity when we work and when we image. And it also allows us to appreciate sometimes a little bit more of nature when you get to battle with those clouds to get just the right picture. That picture kind of holds a little bit more meaning to us at times. So I know that wasn't exactly what Scott was looking for with the cloudy nights theme with, what we do indoors on cloudy nights. I did share one of those, but I think for us here in Montreal, the Montreal Nebula is a fact of life for us. So we work with it rather than, try to avoid it altogether. So with that, I thank you, and I hope to see you live on one of the upcoming GSPs, especially I hope if we get a chance to see the upcoming comet or two visible to us in the night sky. Thanks, everyone. Back to you, Scott.
Well, that was great, Kareem. You might be watching this, but and I hope that you are. But that was a great angle on the cloudy nights theme. All of us that are amateur astronomers have been clouded out or, have experienced clouds in various ways and thought that, that was kind of the end of the observing situation. I've told this story before on Global Star Party, but during the Halley's Comet apparition of 1985 and 1986, I remember going out at what would have been considered the peak of Halley's Comet. And we'd had some great weather in California where I was living at the time leading up to this, but then the weather started to get threatening. And in fact, it started raining. And I had decided that, no matter what, I was going to go out and observe this comet. And at the time I had a 13-inch Dobsonian telescope, 13-inch aperture telescope. And I used to mount this thing on top of my car with surf racks, okay? Because the telescope was so big, I couldn't put it in the back seat and there was no hatch on this particular vehicle. So I would put this thing on top of the car. It looked like it looked like some sort of jet engine attached to the car itself. And so often to the rain I go, I removed the mirror, I put the mirror in the back seat of the car, and I'm driving through the rain, and I get out as far east as I can, but it's still raining, and I'm racing the time when the sun is going to be coming up, and so I go, to heck with it. I'm going to set up my telescope, and I think it was a morning situation. And anyways, I throw the mirror into the telescope, water's running down the tube, the mirror's getting wet, and my eyepiece is getting soaked, and I'm getting soaked, and I have two friends with me, and we start looking up, and guess what happens? The sky parts just for a couple of minutes. It makes a hole in the sky, and it's framing Halley's Comet. And I was able to see it. Of course, there was some blurry, distortion and stuff like that because of the water, but I still see it. And I think that is one of the most memorable cloudy night or cloudy day apparitions that I can relate to you, because it was against all odds. So I say, get out there no matter what. If you got an important observation to make, and don't try to play it too safe. I have another video I'd like to show you from NASA.
Let's talk about fossils. not the dinosaur remnants here on Earth, but the galactic kind. Scientists recently found one that's helping them understand galactic evolution. Just 13 million light years from here is a galaxy called NGC 4945. At its center is a supermassive black hole. It's surrounded by both a disk of gas emitting a lot of light and a bunch of dust blocking much of that light. The galaxy is also in a phase of evolution called starburst, where a lot of stars are being born near its center. Recently, using X-rays, ESA's XMM Newton telescope spotted a cloud of cold gas in NGC 4945. The gas expands light years beyond the central part of the galaxy and pokes out into intergalactic space. NASA's Chandra X-ray Observatory helps study it too by looking at individual bright sources of X-rays within that cloud. Scientists think that the area of cold gas is a fossil of an eruption from a black hole that happened about 5 million years ago. That eruption may have caused the galaxy's burst of star formation. Studying galactic change is hard because it happens over such long time scales. But by looking at lots of examples, scientists can piece together how galaxies like NGC 4945 and our Milky Way evolve.
So I just love the videos and stuff that NASA produces. I think they do just an amazing educational outreach and a service to us all. I am reading some of the chats that you guys are sharing live here with us. And Armando Lee is watching from the Philippines right now, from Laguna Province and Luzon Island. But Marcello, who is our editor of Skies Up magazine, says that he wrote up a fantastic article for this upcoming edition of Skies Up. So we'll have to give that a nice read. I want to thank all of you that have been tuning in tonight. I have another video here. Now, this one is from the European Space Agency about JUICE.
Isolated commands, it doesn't make sense. We're looking at the flight control team do their job. So just trying to analyze their faces, you know. So as long as we don't see any ugly face, we're good.
4 minutes, and then we will reconnect with the spacecraft after half an hour.
So JUICE is right
there. Just behind. It's cool, huh?
Oh, yeah, actually, it's right behind.
Yeah. And then it's coming. I think JUICE on the left side is coming.
It's weird to imagine.
Spacecraft is set.
Yeah, it's right there that I'm looking at it. It's weird.
Okay, not yet, but it's in a few minutes.
That's fast. There it is.
To speaker lab, we have AOS.
OM just speak and we can confirm we have telemetry.
Copy.
Neuf, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage AP, décollage.
One year in space and very busy. After launch, we checked that the spacecraft and the payload were working nominally. And during the cruise phase, we checked that the instruments are working normally. We check every 6 months.
Since the launch, there have been several operations ongoing with the payload in particular, because this is what we are really focusing on in the Science Operations Center. So we had the near Earth commissioning phase with the instrument. So just checking that all the instruments were running smoothly. And this lasted for like 3 months. And then there have been some, let's say, more quiet phase in terms of payload activities, where the team has been starting to prepare the first payload checkout, which is an activity that takes place roughly twice a year, where we check one by one that all the payload instruments are actually performing nominally. So the first one took place in January this year. And the second one is about to happen in the beginning of July. So the first one went very smoothly, and so we spent the first part of, let's say, this year preparing for the second one that would take place now next week.
So you have to imagine that we have a suite of instruments, and they're all fighting for the resources of the spacecraft. They all want to do their science. They all want to use the scarce downlink capacity that we have. They all want to use the scarce power that we have as well in Jupiter. So we need to make up a timeline of activities and observations of the instruments. So the main task when we are around Jupiter and Ganymede will be to actually create these timelines in order to optimize the science return of the mission as much as possible and have everyone and every single scientist happy at the end.
The Jupiter tour is extremely complex, not only from a spacecraft operations point of view, but really from a science operations point of view. So there is a lot of constraints that will be there when we'll be at Jupiter. We have a limited power available. We have limited capacity to send data to Earth. We have also radiation constraints. We have pointing constraints. So all of this, we need to think about it already now, so that we are ready when we arrive at Jupiter to operate all those 10 instruments together. So we've been looking at where and how the science opportunities actually distribute over the tour, and try to understand which science objectives should have priority along the entire duration of the tour. And based on this, we also check at a more detailed, refined level that the operations of the instrument to address the science objective are actually compliant with the constraints. So this is a very long and time-consuming activities. And more than anything, I think one very important aspect is that we need to learn to work together. Not only the Science Operations Center, but the Mission Operations Center in Darmstadt, and also all the individual instrument teams. So we need to learn how to make concession, because not all instruments will be able to work together at the same time. And this is something which is really a learning curve, which takes a long time. So I think the more than 8 years of cruise will be good for that.
So we're going to close to Cebreros, to the S-Track ground station, and which is in the middle of the countryside. And there we're gonna see the 35-meter dish of the main antenna in Cebreros.
Yeah, Al timbre. I think I will have to go out of the car.
They were expecting us, so I think
it's okay. They are opening the gate. As soon as we open the window, it's like.
This picture is about the ESA tracking station network, ESTRAC. Here, currently, we are in Cebreros Ground Station, which is part of this network. This is one of the deep space ground stations. The other ones are in New Norcia, here in Australia, and in Malargüe, in Argentina.
It's also interesting to realize that it's really one of the part of the huge puzzle of the JUICE mission. So basically, it's not only the Science Operations Center, the Mission Operations Center, but it's also here. I mean, everything also goes through here. So it's just the realization of what we think is theoretical is like the fact that JUICE is a huge mission which involves many, many groups and many, many places like this one.
We move files around, we work with digital products, and this is where actually those digital products become something physical. And there's in this digital signal, it gets uplinked or downlinked. There's traces of the work that hundreds of people do, including us, and that's very nice. I think it's a very good reminder from time to time to get out of the box that we usually are in on our day-to-day routine work. We're gonna start receiving the monitoring camera images as well, and the NAVCAM images. So hoping that will go well. We looked at the times where we had the best opportunities to have the most interesting contextual images of the moon, because so the other cameras, the NAVCAM, the navigation camera, and Janus, the high resolution camera, the resolution is so high, and we are restricted by how we can point the spacecraft in such a way that with the higher resolution cameras, we don't get a context of the flyby. We only see a tiny portion of the moon. It's like we see a tree in the forest. Whereas these monitoring cameras, they have a bigger field of view, and we see the context better. So we will be able to see almost the whole moon, also with a part of the spacecraft. So we're looking forward to seeing those.
Hello, and welcome to this live stream from the European Space Agency. My name is Josh, and I'll be your host this evening. We're at ESA's European Space Operations Center in Darmstadt, Germany, and we're excited to share the next roughly 30 minutes with you as our Jupiter Icy Moons Explorer spacecraft, or JUICE for short, flies past Earth's moon. It's returned to Earth this week to carry out the first of the gravity assist maneuvers that will give it the boosts it needs to make the journey. But this isn't just any ordinary gravity assist. This is a special one. JUICE isn't just getting a boost from a planet, it's getting a double boost from a moon and then a planet, our moon and our planet Earth. Right now, as we speak, JUICE has just passed its closest point to the moon, and we have begun to downlink images that it took as it passed from our deep space antenna in Cebreros, Spain, not so far from Madrid. On the left of your screen, you'll see an animation that depicts where the JUICE spacecraft is at this moment. I'm joined this evening by Ignacio, the JUICE spacecraft operations manager. Hi, Ignacio.
Hi, good evening, Josh.
Good evening. You work here at ESOC.
Indeed.
And you and your team fly JUICE.
I'm the leader of the flight control team. Yeah. That's right. So I organize and coordinate the team that takes care of uplinking all the activities to the spacecraft, monitoring the telemetry, following up on the execution of all activities on board. That's right.
Cool, thank you. We also have Nico, the JUICE mission manager with us this evening.
Yeah, hi everyone. So I'm Nico Altobelli. I'm working as a mission manager of JUICE. So this is a role when I try to take care of the entire mission and making sure that everyone can do his best job in the best conditions.
And finally, last but not least, we have Mark, who is one of the JUICE science operations engineers.
Good evening, good afternoon, good morning, whenever you're watching this from. Yeah, thanks for the introduction. In our team, what we do is that we conduct science operations and we facilitate the instruments to reach their science objectives. And during the cruise phase, we're developing the systems that will end up implementing that during the nominal phase.
Cool, thank you very much. And thank you all for joining us this evening. Ignacio, I wonder if you could tell us a little bit about what the JUICE flight control team will be doing this evening, and then maybe also tomorrow evening as JUICE flies past Earth.
Okay, so the flight control team first task is to ensure that the spacecraft is safe and that it's able to perform all required activities. So during this phase, which is considered highly critical, the main purpose of the flight control team is to be ready to deal with any contingency and to react immediately. So we have been training for this event for months now, and we have developed special procedures, including very fast ways to recover the spacecraft, which are not the usual ways in which we would deal with a contingency, but rather accelerated timelines for contingency recovery that would allow us to bring the spacecraft back to a condition in which it would be ready, for example, to perform an emergency trajectory correction if it was necessary.
Yes, so we have the first JMC2 image on the screen. And so we still do not see the moon, which is expected for the acquisition time of this image. And what you can see here covering almost half of the image is the actual spacecraft. These are monitoring cameras. So their focus was to actually monitor the spacecraft. So half of what we will see in these images of JMC2 is actually the spacecraft. We got an update. So this is the first JMC1 image. As expected, it's also dark. And actually, I am not, no, we can actually see the moon already. Yeah, that's the first time that we can see the moon with JUICE.
So maybe Nico, if you could run us through the primary science objectives of JUICE at Jupiter and its mysterious icy moons.
Absolutely. So we are going back to Jupiter. So there were missions in the past going to Jupiter, but JUICE is actually the first one that will not only go to Jupiter, it will orbit Jupiter for a few years and then become the first orbiter of the icy moon, Ganymede. And that's the first time we have a man-made object that will be orbiting a moon which is not our own moon, the one that you're seeing tonight. And the main objective of JUICE in terms of science is, I would say, first to study the icy moon in their global context of the Jupiter environment. Because what we want to understand is how those objects that are made of a mixture of ice and rocks could evolve in a way that is so different from one another, although they were born in the same conditions. And by sending a spacecraft there, we will be able to study at length with different instruments. We have 10 instruments on board. We'll be able to study the different aspects of how the moon are composed, what is their interior made of. At Ganymede, we'll be able to make a real tomography of the interior, and all this always in relationship with the rest of the environment, so to understand their evolution. I think we have nice images coming again.
See what we got. It might either be an AFCAM or a JMC1. So as you can see, this is the next image in sequence from what we had before. So we're seeing more of the moon, and I'm guessing that now images will be coming rapidly.
So what we see here is the last image that we managed to get down on the New Norcia station before handover to Cerberus.
Sort of getting overexposed.
Yes.
No, that's CMC. This is the one on two. This is two, and that's one. Sorry, and then. Where is it?
Yeah. I mean, we already see in normal mode.
Yeah.
No critical events, nothing. There's only this thermal line, which is a bit cold. Very happy, very surprised also because it went super well. Don't see anything. It's like a normal pass, like nothing happened really. Seriously, no events, critical events, no failed commands, no out of limits. Behaved very well, like any other operation.
It's difficult to imagine a more complicated gravity assist because we had everything. We had star tracker blindings, and we had an eclipse, and we had the moon occultation right before the closest approach, and the super tight navigation requirements. So everything was just stocked up, and in the end, the spacecraft has been incredibly well behaved, super quiet, flying, super precise. So it's outstanding. I'm really happy with the results.
The overall flyby phase was about -1 month to +1 month with respect to the closest approach to Earth. So even though we see that we have very dense operation activities near the moon, -1 hour to +1 hour, and then near Earth. So we started a few hours before closest approach, but actually operation extend up to 3 days, the instrument operations. And then we will still have an opportunity to look at the Earth and the moon on the 9th of September, saying farewell until next time. And we will then officially close this phase around the 17th of September when we switch off the SSMM memory and we go back to cruise phase configuration until the next event.
Well, that pretty much wraps it up for tonight. Thanks for tuning in to our program for the Global Star Party, the Cloudy Nights edition. And we will be back with more Global Star Parties. Our next one that we kind of have planned, it's not completely all sorted out yet, but we've got this bright comet coming around as it rounds the sun, and Comet A3, I like to call it because it's easy to pronounce. But that will be for the Northern Hemisphere. So we'll see it in the evening skies. And I expect that we'll see, if it doesn't get damaged on its close encounter with the sun, we've got a great chance of a very, very bright comet. So you want to get ready. Get those cameras out, get your telescopes out, get your binoculars out, And starting on about October 12th, you can see some great views, get some clear skies so you can see towards the western horizon. And, you can go to explorescientific.com/comets and learn more about comets and how to get a good view. So thanks very much. And you guys have a great night. And until next time.
Good day, everyone. This is David Levy. That's me. And I am holding the original Discovery films of our most important comet, Comet Shoemaker-Levy 9. These films were taken on the 23rd of March, 1993. Carolyn discovered the comet on these films 2 days later. And about 16 months after that, all of the fragments of this comet collided with Jupiter, giving humanity its first view of what happens when a comet hits a planet. And one of the exciting things about this is that when comets hit planets, they don't just drop dust. They also drop organic materials, carbon, hydrogen, oxygen, and nitrogen, which eventually turn into proteins, amino acids, RNA, and finally, on one magic day, DNA. Comet impacts are really the first step in the origin of life. I'd like to invite all of you to come to the next Global Star Party. They are run by Scott Roberts of Explore Scientific and me. We co-host this program, and it's usually done on Tuesdays, and usually at 6 o'clock or so Central Time. And so I hope to see you all there. My name is David Levy, and I hope to see you all at the very next Global Star Party. Thank you.